Hey, Darcy McFarland back at you here talking with you a little bit about how we use math in the trades. I want to talk a little bit today about slope or pitch of a roof. And so you might have heard things like people talking about a 412 roof or a 612 roof and wondered what that means, okay? Well, that's just slope. It's rise over run, okay? And so the reason we use 12 is it doesn't seem like it's reduced. If I said a 412 roof, I might be asking myself, well, why don't I say 1/3? Why don't I reduce that fraction down? And the reason is because that's given to us in inches, and they're using 12 inches as a standard because that's 1 foot, okay? So what that's meaning is that for a 12-inch run, we have a 4-inch rise, and that's going to be the slope of that roof. So for every 12 inches, okay, so we have 12 inches here, we're going up 4 inches there, all right? So now this gets into just some simple ratios. So if I had, and a little bit of conversions, so if I had a house here that was, let's say it's just a little shed or something, and we're 4 feet here, okay? So 4 feet is 48 inches, right? So if I wanted to kind of calculate what this peak height here would be, right, I would just set up a simple equation, right? So I would have 4 inches over 12 inches equals x that we're trying to find, right? So x over 48 inches, okay? And if I multiply that out, 4 times 48 divided by 12, I would see that this here would be 16-inch rise between here and here on a little shape, okay? Now, we talk about different types of slope, right? We may talk about 6/12, so that means that for every 12-inch run, we have a 6-inch rise, okay? Or 8/12, or 10/12, okay? And so on and so forth. So again, we would just do the same process here, but with 6/12, we can calculate some of these heights, okay? And then once we have these heights, right, then we can use a squared plus b squared equals c squared. So we actually have our distances here. So we got 48 inches, we've got 16 inches. We can actually use a squared plus b squared equals c squared and now calculate that height. And I won't do that math, but that's how we would use the Pythagorean theorem, as well as slope and some ratios and some cross multiplication all together to calculate some of those things. And so here's an example of where and why we would do that. So to build this, okay? So this is a different pitch that I've drawn more like probably about a 6 or an 8/12 there, but right? So this is a 4/12 rafter, so it would look kind of like this, right? So we would use this method to find out this length, okay? And we've also got some angles involved, okay? So we've got a quick square where we can take and put a pivot point on here, and we can take and pivot it like this, and we can go to the 4, indicating a 4/12 roof, and it shows me what angle to cut this to. So it shows me to cut this to 18 degrees, okay? Now, on a miter saw, this here actually is 72 degrees. So we could also use trig and find this angle, which is 72 degrees, but the 18 degrees is what we cut off of the miter saw, because the miter saw cuts off of 90. So we're actually cutting that 18 degrees off. So there's a little bit of understanding angles and things like that in there as well. There's also some parallel lines, right? So when we look at a rafter, okay, if we're cutting this to 18, we want to cut this to 18 too, so that this is parallel with this, so that when I put on my fascia, that's the steel stuff you see that trims off your house nice, we want that to be straight and parallel with the walls. We don't want to leave this out like this and have our fascia coming out on an angle. So we've got to, cut that same angle twice and make it parallel, okay? Similarly here, this little notch that we cut in so it can sit on the wall, and we call that a bird's mouth. So if we cut that bird's mouth, right, that sits level, we want to take and cut this at the same parallel line, right? So that when I put the soffit up underneath, it sits perpendicular to the wall, right? We don't want to put the soffit up like this and have it going up on an angle, right? So it's all about visual aesthetics, and that gets into some parallel lines and angles and things like that as well. So that's how we use a variety of math skills for something simple like building a little shed in your backyard.